Hey, is anyone there? Hey, can y'all hear me? Hey, is anyone there? Hey, can y'all hear me? Hello? Hey, is anyone there? Hey, is anyone there? Hey, can y'all hear me? Hello? Hey, is anyone there? Hey, is anyone there? Hey, can y'all hear me? Hello? Is anyone there? Hey, is anyone there? Hey, can y'all hear me? I have no idea what's going on here. Is this a broadcast or a Google Hangout? Okay. Well, if you guys can hear me, if like I can't hear you for some reason, but if you want to go ahead and start talking about questions we might have, if you want to ask the group a question, maybe we could start with talking about homework 2. And if you could type out the question as well until I figure out why I can't hear you. So type out the question and maybe the answers. Sorry about this. It seems a little wonky. I have no idea what's going on here. Yeah, I mean, they keep saying they can hear me, but I can't hear them. Hear you. Hey, Tiffany, this is Michelle. I see your suggestion that we do, oh, here we go. Try navigating to this hangout, it says. Okay. All right, I'm gonna give that a try. Sorry for this. Emery's joining out. Hey, can anyone hear me?
Yeah, can you hear me?
Ah, yes. Okay. Sorry about that. I don't know what's going on here.
Yeah, I don't know. I think it might have to do with the difference between a broadcast and a hangout. Did those guys click the link? I guess we'll find out in a second.
I guess we will. Yeah.
Hi, Ankur, is that you?
Yeah, hey Emery's, hey Michelle.
Hi, how's it going? I don't know what's going on here.
Yeah, I don't know. I think it might have to do with the difference between a broadcast and a hangout. Did those guys click the link? I guess we'll find out in a second.
We will. Yeah.
Hey, Hi, Ankur, is that you?
Yeah, hey Emery's, hey Michelle.
Hi, how's it going? I don't know what's going on here.
I think it might have to do with the difference between a broadcast and a hangout. Sometimes get too loud. Everyone mute their speakers.
Hello?
Hey, is this Tiffany?
Yes.
Hi. This is Michelle. I think it looks like everybody's muting their microphone.
Oh.
But
Just told to.
there we go.
It'll feedback if you don't leave it muted. So if you're not saying anything, we should leave it muted.
I see. Okay.
So, were people mostly interested in talking and working on the homework or preparation for the exam?
I was mostly interested in talking about preparation for the exam, but I thought we could open up with questions for homework too, since it's due tomorrow, in case anyone has any burning questions.
Did anybody get the first problem, which was was it KNN with P equals 100? All those corner cases.
I have not tackled that one yet. I was also a little confused on that one, so I was holding it out. So if anyone has any answers about problem one or any guidance.
So, so for the P equals 1 case, it was kind of straightforward. You're calculating the area under a trapezoid once you kind of figure it out. For P equals 2, it's sort of like the area underneath a pyramid with some weirdness in the corners. A truncated pyramid, a pyramid with the top cut off. But P equals 100, it's crazy at the edges and the corners. And so I was sort of hoping we could not worry about that. I was also hoping someone would say, "Oh, there's a clever trick, and you get the exact answer by doing this," but I wasn't sure how to do that.
Yeah, clever tricks are great. Anyone have any guidance for problem one, the second part?
So this is the KNN. Hi, this is Ankur, and I guess we can say our name when we begin because we are introducing to each other. So to answer your question, I'd solve the problem one. The way so P is equal to 1 feature. Think of it as a line, right? P is equal to 1. So you look at x varies from 0 to 1. So if your x is 0.6, you look at the observations between 0.55 and 0.65, that's 10%. So if your x lies between 0.05 to 0.95, you are looking at 10% of your entire line. So your answer for part A is approximately 10%. So if you're looking at a 10% of a line and you move to part number B, you are essentially multiplying. You're looking at the square of 10% on one line and 10% on x2. So your answer is 10% multiplied by 10%. And I'll just go real quick here because if you have any questions, I'll be very happy to help share some of the approach I have. And part C again, you have 10% multiplied by 10%. Multiplied 100 times. So it's 10% raised to power 100. Part D, you have like 10% raised to power of P, and when P is very large, this will go towards 0. Part E, P is equal to 1. So you can say the line length is 0.1. P is equal to 2. Actually, part E makes it really clear because it tells you the geometric shape you can imagine. So P is equal to 2, it's a square, so your answer would be square root of 0.1. I hope it makes sense. Was it helpful? Hello?
So I think the point is, though, that that's just an approximation, right? Because if you're at point, say 0, 1, in the first case when P equals 1, when it's just a line, at the edges to calculate the average correct, you have to calculate the area under a line, basically.
Yeah. So I think, what's your name? Sorry, I didn't get it.
Oh, sorry, I'm Jeff Sink.
Okay, so statisticians are never absolute. They always talk like it seems, it appears. We talk about averages. So it's a very confusing world.
Yeah. So that's a good answer. I mean, the good answer is the approximation is good enough. You don't really have to approximate in the P equals 1 case. it's a undergraduate calculus problem or high school geometry problem to calculate that average. It's a little bit harder in the p equals 2 case, and it's almost impossible in the p equals 100 case. So, I wasn't sure whether they said average to mean approximate the average or average equals the average, right? And so,
Sure. If you have, Jeff, if you want exact answer, I also did that calculation, and I'll be, I'll be happy to share that. So the simplest way to look at it is imagine part A, right? Part A, if your x is between 0.05 to 0.95.
Actually, I think if you could jump right to the p equals 100 case, that'd be awesome.
So p is equal to 100 on a single line, you're looking at 10% of the fraction on that line, right? And imagine it's a cube, which with each line, on each line, you look at 10% of the values. So you multiply 10%.
I'm talking about the edge in the corner case.
C, right? Part C?
Right. But if we want to solve it exactly in the p equals 100 case,
Yeah.
that's the hard one. So yeah, you're right about the meat in the middle. I understand that completely. But the edges where it's like, okay, variable 1 is close to the edge, variable 59 is close to the edge, but the other ones are not close to the edge at all. Or variable 1 and only 1 is close to the edge. Or variable 59, 39, and 10 are close to the edges. You have all these weird shapes to average over. That's the problem.
Imagine a cube. If it's a cube, right, with p is equal to 100 case, when it's a 100-dimensional cube, the volume of that cube is length of each raised to the power of 100, right? Is that correct? So hey, square, the area of the volume of a square or area of a square is L square. The volume of a cube is L cube. Volume of a 4-dimensional figure will be L raised to the power of 4. Volume of p dimensional cube will be length raised to the power of p. Make sense?
Yes, of course.
Yeah, so you're looking at the 10% on each line.
And all that analysis applies to the center, right? But once you're close to the edges, once any of the variables applies to the edges, it's no longer 0.1 for that value. It might its length, its edge length might be short, right? Because you can't stick out past 0, you can't stick out past 1, right? So as you get close to the edges, your interval width shrinks, right? So if x1 is, for example, if x1 is 0, right? Its length is 0.05, right? So it would be 0.05 times all the other dimensions 0.1, right? So it's not 0.1 to the 100, it's 0.05 times 0.1 to the 99. And if it's close, see what I mean? And so if it's like 0.025, it would have a different length times all the other dimensions in their lengths. So it's not always 0.1 to a dimension. As you get close to the edge, your intervals get truncated, and in the extreme, when you get to the edge, it's only a half of the width that it usually is. And so, as you get close to the edge, your interval decreases linearly as 2 of your dimensions get close to the edges into a corner. Then each of their things shrinks linearly, and so you actually have a combination of all possible subsets to the 100 of ways of getting to the edges and corners. That's how I read it.
I see your point, Jeff, and I think what we need to approximate here. To do an exact analysis, you're right. If it's less than 0.05, we don't look at the values after 0. Like if x is 0, then you cannot go below 0 because x is 0 and 1. So for the extreme side, there is a case when you're not really looking at 10% of the values, but really you can approximate, or you can actually, I can share with you the exact, which is close to that 10%. Yeah. Yeah.
Cool. I'm cool. Let's move on.
Yeah, I hope it helps.
Yep.
Okay, any more questions on the homeworks?
We haven't covered bootstrap yet in the class, so that's a technique, I guess, and linear discriminant analysis. So these two techniques, if they come on the exams, I would be pretty scared.
So each of those has a different issue. The one, is in a chapter and that we talked about, and it's on a homework that we were supposed to do. So that's fair game, I think. The QDA and LDA, I think if anyone shows up not prepared for those, you're going to look very foolish if there's a question there because you just can't make it up, right? The bootstrap is actually a different situation because I don't think that personally would be a fair a fair exam question because we haven't quite talked about it in class yet, have we? And
We're actually going to cover it in class tomorrow. That's what it says on the schedule.
Exactly. So I guess I'm wrong. It wasn't a fair homework problem because you basically had to read ahead and do it ahead. So it was a fair exam question for Wednesday, but it's not really a fair homework question for tomorrow because we haven't actually done it. But I think both of those, QDA, LDA, and bootstrap, are going to be on the exam. I think, thankfully, the amount of material there isn't that big, but it's I'm personally preparing as if it's going to be on the exam.
Yeah, try to dig deep into that, and makes sense.
Yeah, there's so many when you're reading those sections, there's so many funny little things that are going to be so hard on the exam. I think I'm personally not very good at memorizing things, and in the LDA section, it goes into talking about things like sensitivity, specificity, false positive, false negative, and it's a long series of definitions of words that all kind of sound the same, even to someone like me who's a native English speaker. And so it's like a long series of synonyms and definitions of ratios of this to this is sensitivity, this to this is 1 minus specificity. Those things would be very good and very easy exam questions. They're also very hard to prepare for without just blatantly memorizing things, which I'm terrible at.
I have no idea about the midterm exam, what kind of questions may come,
I think about that, I think your best bet would be to look at the final exam and then just subset to the midterm subjects.
Oh, that's on the website?
Yes.
Oh, okay.
It's on the schedule, on the same schedule where you see the PDFs, links to the PDFs for the lectures. There's also a practice final exam. And the final exam is cumulative. So in particular, it has a good feel, a good sampling of midterm exam questions.
Perfect, thank you.
As for me, I feel like I could memorize the definitions, but memorizing the formulas and looking at I feel like I understand what they're doing conceptually, but to replicate the formula and solve
that. I think they were pretty clear that we're not expected to memorize those formulas for standard error of betas and that kind of stuff.
Yeah, they said they'd give us a sheet that had the formulas on them, but even to know the components of what comprises the formula.
The trick, in my past life, whenever I was given one of these sheets, people specifically don't do a good job of identifying what is what. It's just a list of formulas. So you do have to know the formula well enough to recognize it. Okay, I'm looking for that formula that kind of has, this and this and this. And then you go find it, right? There won't be a formula that says, I doubt there'll be a formula that says, standard error of beta equals this formula, I think you kind of have to recognize things in the list. So you do need to know the general shape well enough to know it when you see it. But I think any of those formulas is going to be given to us.
Okay. Well, that makes it a little less scary, I guess.
I was foolish myself. I in class, he said that, we would have a sheet of paper
Right.
to bring in. And so mentally, I was preparing myself, like, a lot of things I was trying to understand and really grok. Other things I was like, I can just write that down. It'll be there when I need it, if I need it,
Mm-hmm.
But there's there's no like external memory for me. So I have to actually internalize all these funny little things, at least in the short term.
Right. Are you taking the midterm in class?
Yeah, I'm actually north of San Francisco.
Okay.
So it's, an hour for me to get down to campus. So I was just going to take a day off of work and do that.
Okay. Well, that's the.
Solution into this final exam too, Samir?
I don't remember seeing that.
I don't think there are solutions to it. I think it's just the questions.
Yeah, you're right. I couldn't find the solution. Have you guys been able to understand the textbook, chapter 4, chapter 5, get all the understanding?
Yeah, this is Emrys. The textbook is excellent if you guys haven't been reading it. It's really a pretty incredible stats textbook as they go.
Really? I've been pretty unimpressed with it. Only because, like for example, the one thing that bothered me was there was all this, a big section on the Bayes, a Bayes estimator or Bayes classifier, right? And talking, and I'm like, well, how do you figure this out? Is there a formula for it? And then that section ends, and I spent an hour trying to figure out so how do I figure this out? And then the next section was going on to another subject, and it says, oh yeah, by the way, that Bayes classifier, it's completely theoretical. You can't really do it in practice. In practice, you do this. So in that whole section on the Bayes estimator, it never really says, by the way, it doesn't exist. Or you can never get your hands on one, or it's a theoretical topic, not a practical one. I found it was a bit disorganized. And also, I personally am kind of leaning a lot on statistics I learned before when it comes to p-values and confidence intervals, things like that. If this was your first exposure to confidence intervals, I don't think you would be in a good shape right now. I think there's a lot of background information they're quietly assuming that everyone knows.
Yeah, that's true. I agree with that. That's a good point. You do have to supplement it. But I think as far as versus what he covers in the class, it gets to the same level of detail.
Yeah, I completely agree.
So I do have, this is just a shameless plug for a question I asked in the Google group. For whatever reason, I cannot find the list of office hours that are held online. This is my 6th or 7th SCPD class. And previously, before exams, they tend to have pretty comprehensive discussions in the office hours for the SCPD students. And for whatever reason, I don't know if he sent that out as an email or if it was online and now it's gone. Do you guys have that reference, Andy?
Hey, Emrys, this is Ankur. So I saw your question. I was looking for that. On the website, if you go to course information, they have recently added that with the office hours for hangout Friday 6 to 8 p.m. So let's see how useful they are. But obviously, then Friday 6 to 8 p.m.
There's other hours now. Looking at the list before the exam, there's another one Monday morning. That's Pacific time.
Or it's online.
And there's you're right. So these are true. There's only one that's a Google Hangout. That's on Friday. Yeah.
Google Hangout
And
from 6 to 8.
yeah, you're right.
So how are you guys practicing for midterm? Like reading the book,
Doing all the problems in the book.
all the homework, all the text problems.
All the problems in the book.
Yeah.
Yeah, if you go in not knowing how to do all the textbook problems, I think you're a fool, because it's like, you know, it's the best way of measuring, getting the knowledge that the writers of the textbook at least expected you to get. You know, it'll help clarify things, get them in the right order in your head, and you know, you'll look terrible if the question was just problem number 1 from the textbook. It's just sitting there and you just didn't bother to do it. So you should have at least all the homework problems, all the homework of course, but all the textbook problems in your head. Some of the sticky little subjects are bothering me, like ROC. There's a curve of the ROC curve, or the area under the curve. Little topics which are kind of mentioned almost in passing. I'm not sure how much of a deep dive we need to go into those ideas. So those are the ones that I'm afraid of, that don't take up a lot of volume in the book, or even volume in the questions, but still would be a fair question. And I'm not sure if you poke me too hard about my knowledge of ROC, I probably would fall over.
Yeah, I don't think he really, didn't he touch on it in the lecture, but didn't really go into depth or anything like that.
Yeah.
I understand it conceptually, but how to calculate it, I don't know. I mean, I've used it in my work, but you just, you know, you
Really?
yeah.
Yeah, that's awesome. That's lucky. You're so lucky.
Well, but,
That's
but
the
it's,
first time I ever heard of it.
oh, really?
Yeah.
I guess it's like some people think it's a better measure than of your model's performance than a confusion matrix. So I don't know if that's true. I'm not that well versed on it, but I mean, the only thing I get is a result that says that the area under the curve explains 87% of the variance in your model. I think it's similar to like an R squared or. So I don't know a lot about it conceptually, but I know what it means basically, and and I can see the number and know if it's a good result or a bad result, I guess. So.
So the area of the curve, do you want that to be near 1 or near 0? Like what's the better one?
1. You want it to be to the upper left.
I see.
So does anyone have like specific questions about some of the concepts that we've covered? I guess one thing I'm kind of a little confused about is the bias variance trade-off.
Yeah.
I understand bias and variance like as concepts, but how do they impact it? Oh, go ahead.
The variance should be in your head a little bit more than a concept. It's kind of real, right? The bias is always going to be a concept, but the variance is actually a bit more real. It is actually a variance. It's like if you trained your model over many different training sets, it's the variance of your estimates, right? So imagine like this comes up in the group. Set your trained data set one at a time. So you leave one guy out one at a time, right? So if you have a training set with n guys in it, you'll have n training sets with n minus 1 in them. and then train your model over that. All those different things. The variance of that is the variance of the variance bias trade-off. And so what it means is it's like your sensitivity to your actual. It's your sensitivity to your training set. If you're sensitive to your training set, you should think that you're overfitting. Meaning if you took 90% of your data versus 100% of your data, you should get pretty much the same model. If you don't, you're oversensitive to that 10%, right? Bias for me is still just an abstract idea. Bias is the idea that your model is complicated, but you're under modeling it. And so I personally think of bias as being like an underfitting problem. Like, oh, it's really quadratic, but we're trying to model with a line. Oh, it's really cubic, we're trying to model with quadratic. Or it's highly nonlinear, we're trying to model it with something which is almost linear. So that's bias. Unfortunately, bias for me doesn't have a nice of an interpretation as the variance does, and I haven't seen one in the book. So it's just that's more of a concept. And the other important things about these is that for a given model, the two kind of trade off, right? That as you increase your variance, you usually decreasing your bias, right? For a given model, as you increase your, say, flexibility. But as you jump from model to model, that's not necessarily the case, right? So you sort of hope that if you get a model that, as you jump from model A to model B, you sort of hope that, ideally you would have low variance and low bias, right? You could actually decrease both. It's just better, right? Mm-hmm. Just in an absolute sense, better and better. And that would just be awesome. It might actually be better in one, but be worse in the other. So it might have more bias, but somehow compensates by having much less variance, something like that. Okay. So the trade-off is specific only to one model, and not as you jump around models. He brought that up in class a couple of times, and it's probably worth knowing.
Thank you. That was really helpful. Thank you. Oops. Thank you. That was really helpful.
If anyone has a better interpretation of bias, speak up, because I have mine, but I'd almost like to have it a bit more like variance. If I had to, I'd almost write down a formula for it, but not the bias. If anyone has a stronger feel for bias, give me a shout so I can put it in my head.
Does anyone have any explanation for leverage points that have or observations that have a lot of leverage versus those that are outliers? I think when people are talking about, when they say outlier, they're actually talking about an observation that has high leverage, I think.
So the difference there is outliers are skewed in the vertical direction, and the leverage are skewed in the X direction, horizontally. So a high leverage point has an extreme value for X, and an outlier has an extreme value for Y. That's his fan. And some points might have both, of course.
Oh, cool. Thank you. Does anyone else have any burning questions or anything like that? I don't want to monopolize the conversation. Okay, well, I have a general question about the, if anyone has taken classes through SC's PD, just about generally how, like, my understanding is that the test gets emailed to your test monitor, your exam monitor, and then they give you the test and the instructions, and then I guess we just have an hour to do the test because the class lasts an hour, and then they sign it and fax it back. Does anyone know the details of how that works or anything like that?
So the class is an hour and 20 minutes from 4:30 to 5:50. I don't know if that's all actual class time, but it's more than an hour.
I noticed that. I didn't know if it was just because it varies. So I didn't know if the class was actually scheduled for that long or if he just ran long sometimes. Okay, so that's good to know.
So I don't know about any of the details, but you'll have more than an hour, I would think. Are you taking yours at your work?
Yeah, I have to. And we're Central Time, so I can't take it during the class time. So I'm like, oh, I guess I'll do it early or whatever. I don't know. So
Yeah.
I'm kind of nervous about that. It'd be nice to do it in person. So you said you're doing it in person, right?
Yeah. I definitely personally thought I was definitely past the point in my time when I'd be taking timed exams, but here we are.
No, here we are. Yeah, I know. Well, it sounds like you're pretty, you're pretty solid on your knowledge. How about everybody?
You haven't asked any questions on Bootstrap yet. I haven't been getting there yet.
Okay. I started the homework, or not started the homework, but I started the homework problem that deals with Bootstrap.
I did I knew I was going to need to prep for the exam, so I did my homework last week.
Good for you.
Yeah. And in fact, I think personally myself, I was going to do the next 2 homeworks over the next week or two. Just, basically I could just read ahead and get it done, get it out of the way and start the project. I don't think I'm going to sit for the final. I'm just going to do a moonshot and try to get to the project done.
Okay.
I wish we could do the project, get our grade back, and then decide to sit for the exam.
I know. I'm gonna do both just to hedge my bets. So, but yeah, I wish they would tell us so that way we could know we didn't have to take the final. But
yeah.
So, how does everybody else feel? Are you guys gonna do the class project for sure, or?
Yeah, I mean, probably. Just anything you can do to increase the likelihood of doing well.
And looking at the grades for homework 1, it looked like everybody did pretty well. I don't know if there's grade inflation but it looks like everybody got in the 30s at least.
Yeah, so in general, in these S&E courses, especially for the masters, all the students on campus are working together in these homework groups, right? That you may or may not have as much access to, and so a big differentiation happens around the exams.
But the funny thing about that, the final, in one of the little write-ups about the final project, it kind of sounded to me, it was like a little nudge, wink, wink. We expect everyone to get full credit, That's how I kind of took it. Hey, if you jump through all the hoops, you'll get full credit, And so I took that as a sign that everyone should at least attempt the final project, if not counting on it.
Well, I'm definitely going to attempt. So it doesn't seem like on the face of it, I'm not too worried. I don't think it's going to be too hard, but we'll see once I really get into it.
I find in the statistics, especially when it comes to inference and all, it's pretty easy to write very subtle little questions that kind of require you to finesse out the differences between this and that, you know, and it would, you know, if they wanted to make a really, really hard exam on this material, they could. Like, and that's what I'm kind of afraid of. So, like, not having a timed final for me would be awesome. So.
So one of my friends is doing a similar, he's doing a master's at Northwestern, and that's how they do it. They have, I think you have a week, and then you have to just turn it in on Sunday night. So you can really work on it for a long period of time. But an in-class final means too that it can't be too terrible. I mean, it can't be too like 1,000 questions, you know, because it has to fit into that hours or hour and 20 or whatever. So that's something comforting, I guess.
Yeah. Cool. Is anyone interested in working on the final project? Starting somewhat soon. I mean, time's going to fly. And so I'm personally by nature not someone who works with other people, but I don't want to put myself at a disadvantage if everyone else is working with people, you know. And so if anyone's interested, I'm kind of looking for someone. It would be hard to work remotely like this, but I think we can make it work.
Mm-hmm.
And for most of us, we don't have much of a choice. So.
Yeah, that I think that would be good. Anyone else want to like participate? I don't know how it would work. I guess you have to like just talk about it and then you do the coding on your own.
So I think actually you do the coding on your all the fingers on the keyboard or your own pencil paper your own. But you know you can make the models together, everything. You know you can come up with all the same plan, all the same strategy. You can really work together. Just the write-ups have to be your own. That's how I read the descriptions.
Well, I'm interested. How about anyone else kind of want to get in on this?
Yeah, I'd be interested.
Who was that?
Sorry, this is Emrys McMahon.
Oh, Emrys. Great. So Michelle and Emrys, I'll reach out to you guys offline, okay?
Okay, that sounds good. Thank you.
That sounds good. I'm actually going to run. Thanks for organizing that.
Thanks for coming.
I'm gonna get off myself, and
Okay.
But if anyone has any questions, feel free to. Yeah, I wish there was like a subset of the Google groups, like dumbass questions,
I know.
like subgroup. Like that way, you would only go there if you also had a dumb question,
Right.
you know? Because I don't want to pollute the big board with like, so what the hell is going on here? You know?
So what? Yeah. I know what you mean. I think everyone feels that way though.
Yeah.
It's just looping as well. This is Ankur.
Okay, great.
Thank you.
So we might, there's 4 of us. I don't know if there's a maximum. If so, we might split up into 2 groups. Okay?
Okay, that's fine. Thanks a lot.
Cool. Great, everybody.
Thanks for your help.
Have a good weekend. Good luck.
Okay.
And I'll see you on the posting boards.
Okay, cool. Bye. Well, that was totally useless.